Hello, this video is for lesson 10. So you're writing lesson 10 in your math notebook, and then we're going to start with a warm-up. So the first problem is asking you to find the GCF using a factor ladder, and the second problem is basically order of operations, because there's a particular order that you need to do math in. We all have to agree on what the right answer should be, and if we follow the same order, then our answers will be the same as other people doing the same problem, which is what we want. So notice when I factor using a factor ladder, it doesn't matter if I'm doing 1, 2, or 3 numbers, I always write down my prime factors so I know what I'm trying to divide out. I have 3 numbers, so I'm going to make kind of a long ladder with 126, 70, and 140. And then I go ahead and look at my list of primes, and I try to find a number that is divisible into all 3 of those. And if they're even numbers, 2, of course, is the easiest choice. So when I divide 126 by 2, I get 63. 70 divided by 2 is 35, and 140 divided by 2 is 70. Now I go back to my list of prime numbers, and I'm looking for another number that can divide into all 3 of those. 63 is not even, so I know 2 doesn't work. If I add 3 plus 5, it's 8, so I know 3 doesn't work. 63 doesn't end in a 5 or 0, so 5 doesn't work. So I keep going through the list to make sure I can find a number that's divisible that goes into all 3 of those numbers. If you look in a multiplication chart, if you look in your sevens and you go down the column or the row of sevens, you'll see that all 3 of these numbers are in the same row and the same column, which means they're divisible by 7. So if I divide by 7, 63 divided by 7 is 9, 35 divided by 7 is 5, and 70 divided by 7 is 10. Now, when I get to this point, I'm still trying to figure out if I can continue dividing. And I look and I see this isn't even, it's not divisible by 2, 5 is not divisible by 3, 9 is not divisible by 5. Now I'm on to 7. None of these are divisible by 7. And then when I get to 11 and 13, those are bigger than the numbers that I'm looking at, so clearly not divisible. This is where I end my ladder, and then I just have to remember that the 2 factors on the side need to be multiplied together. So my GCF equals 2 times 7, which is 14. That's how you find the greatest common factor. Okay, now I'm on B, and I'm going to remind you that the order of operations, the first step is parentheses. The second step is exponents. Third step is 2 operations, right? We're going to do multiplication and division, and then the fourth step is addition and subtraction. And remember that these 2, you must go from left to right. So just because I write multiplication first doesn't mean I always do multiplication first. I have to go left to right. All right, so I'm going to rewrite the problem over here so that I give myself enough room to show all of my steps and I don't lose any numbers along the way. Now I'm going to do the denominator first, and then I'll do the numerator first, and then I'll work with the denominator. Okay, so the first thing is parentheses. So I do the math inside the parentheses, and notice that the 9 minus 7 is 2. I'm going to keep the parentheses and put the exponent there, again, just so that I don't forget a step. And now I'm going to do the exponents. 2 squared is 4, so I get 20 divided by 4 plus 5 times 4. Now remember I said with multiplication and division, you do whichever one comes first from left to right. That means I'm going to do this number first. So 20 divided by 4 is 5. So now I have 5 plus 5 times 4. But remember I need to do multiplication next. So I have to do the 5 times 4 next. So I have 5 plus 20. And then this becomes 25. That all is the numerator. Now the denominator is easy, right? It's just 4 plus 5. So now I have 25 over 5, which equals 5. Phew, that was a lot of steps, but as long as I kept going back to the order of operations, then I know I'm doing math in the correct order, and I will get the right answer. All right, next, you can put a squiggly, well actually this part you're not going to write down, so here's what I want you to see. we're learning about factors and multiples. So far, we've learned a lot about factors, right? So we've been working on factors. Those are the smaller parts, smaller numbers that you multiply together to get a product. And we looked at a list of factors that looks like this. And with this list, you can see, I'm calling it a factor chart. And remember, we noticed, except for one, it's not prime or composite, we noticed all the prime numbers had only one pair of factors, right? Exactly two factors. Every single prime number on this list has only two factors. And then we noticed the composite numbers has 3 or more factors. And so some of these numbers have a whole lot of factors. And the factor list for each number, it's relatively small, right? This list doesn't go on forever. But when you start getting into multiples, I want you to look at this list. This is a multiplication chart, right? And multiplication chart, these multiples go on forever, right? In this direction, I would keep going. And in this direction, I would keep going. And notice that the numbers just keep getting bigger. And so when I look at a multiplication chart, that has to do with multiples. And when I look at a factor chart, there aren't as many. And so you want to keep that in mind when we're doing the next couple of lessons so that you can kind of keep track of the difference between factors and multiples. So I'm going to move this chart over now. And I'm basically going to show you the examples, the difference between factors and multiples when I look at the numbers 10, 20, and 30. So notice for 10, if I make a factor chart and I just do a list, right, the factors are 1, 2, 5, and 10. But the multiples in a multiplication chart are skip counting by 10. And these multiples go on forever. I'm trying to move the multiplication chart back. Okay, so notice I've got the 3 dots. They go on forever to infinity. There are so many multiples. I'm not going to write them all. But guess what? I can write all the factors. And now let's look at 30. So if I keep going down this list and I show you the, where am I? If I show you the factors of 30, my box is getting a little messed up there. So when I show you my list of factors for 30, yes, there's quite a few, but when I show you the multiples of 30, right, again, it goes on forever. When I look at the factors of 12, there's a certain number, and the multiples of 12 go on forever. So here's how I look at it, just to remind myself the difference between factors and multiples. There are just a few factors, right? There's fewer. There's a smaller number. But multiples are many. So you're going to hear me saying multiples are many, factors are few. Factors are few, multiples are many. The factors are the smaller numbers that you multiply together to make a product. And the multiples, yes, you can think about multiplying them, but they're more like skip counting and like a multiplication chart. Okay, next. Now, draw a little squiggly line underneath your warm-up. This is what you're going to write for your lesson today. And this is lesson 10, and it is 1.6, and we are learning about, I'm just going to abbreviate it for right now, least common multiple is abbreviated as LCM. Okay, so notice I want you to write down factors are few and multiples are many. Write that down. You definitely want to remember that. I hope it helps you as much as it helps me. And then your definition of a least common multiple, right? So the least common multiple, we abbreviate it as LCM, is the smallest multiple that is shared by 2 or more numbers. So notice the common, just like the greatest common factor, right? There's some common multiples, but this time we're using the least. And the least common multiple, I don't know if you've heard of this. Maybe you've heard of the least common denominator. So we use the LCM to find the least common denominator. I'm going to put in the word denominator. So this is what we do when we add fractions that have different denominators, this process. So it's good to know. All right, so here we go. This is from the textbook. You can see this is on page 38. The idea is I'm going to ask you to find the least common multiple of 4 and 6. The reason I would do that is this. If at some point in my life I'm adding 1/6 plus 1/4, If I look at what it actually looks like, I could just kind of make a little picture of 1/4 and 1/6. And so if I break this rectangle up into 6 and I highlight 1/6, it's that little piece right there. And if I break this size rectangle, which is the same as the other rectangle, and I only cut this one up into fourths, this is 1/4. Now the idea with fractions is, if I want to add them together and name a new fraction that represents these two pieces together, I can't add 1/4 and 1/6 because they're not the same size pieces. Yes, I would have two pieces, but they're not equal. So this is why we're learning least common multiple. All right, so here's what you want to do. You want to make a list of multiples. List the multiples of each number. Oh, that's easy. I'm skip counting by 4s. 4, 8, 12, 16, 20, 24, 28, 32. I could keep going, but usually 6 or 7 is enough. Now I'm going to list the multiples of 6. 6, 12, 18, 24, 30, 36, oops, 42, ... Okay, so in this list, I could start circling the common multiples. I can circle 12 and 12. What else do I see that they have in common? 24 and 24. But notice what I'm trying to do is find the least common multiple, which means the smallest number. So these are my two smallest numbers, so my least common multiple is 12. All right, so this is an OYO, so you are doing these on your own. So I want you to go ahead and pause the video and try to find the least common multiple of 3 and 8, 9 and 12, and 6 and 10. Pause the video, do the work, and I'll show you the answer. Okay, so when you're doing the multiples of 3 and 38, you just list, like I said, 6 or 7 is usually enough. So there's my list of multiples. If I wanted to, I could keep circling all of the common ones, but it just kind of makes sense to look for the smallest one in the list. And so if I go through, so these numbers are bigger, right? They're further apart. So I might want to start looking at 8 and to see if 8's up there because there's fewer numbers here. 16's not up there. 24 is up there. 24 is the least common multiple between 3 and 8. And then I could do the same thing with 9 and 12. Oops, I want to grab this. Oops. Okay, here are the, oops, that didn't work. Where is my little window? Okay, there's my list of multiples for 9 and 12. And then again, I usually start with the list that has fewer multiples in it. So I'm looking, I see the 12, 24, 36, 48. That's kind of strange. I don't have enough numbers here. Wait a minute. Oh, gosh, I almost missed that one. I was going to start adding more multiples because I didn't think I had a common factor. A common multiple. Well, okay, it's a good thing I took a second look. So there we go. I see a 36 and a 36. So the least common multiple, the smallest multiple is 36. So what I was going to show you is if you don't find a common multiple in the list, you might just have to add some more multiples. Okay, so now let's take a look at the ones on the bottom. This is for 6. I have the first few multiples listed for 6 and 10. And then I'm going to go through this list. I see a 10, 20, oops, I see a 30 in both of those lists. So the least common multiple for 6 and 10 is 30. Okay, so the other way you can find a least common multiple is to use prime factorizations. And so you probably remember how to use a factor ladder. So here's the idea. I've got 16. And if I did a factor ladder, this is what I would end up with. And if I did a factor ladder for 20, this is what I would end up with. So here's the idea that if I know the prime factorizations of the numbers, so once I have all of my prime factors, here's the idea. I kind of use the scenario of I want a little bit of what all of my neighbors have. And so if this is the neighbor that's on the left side of my house, and this is the neighbor that's on the right side of my house, and I'm trying to keep up with my neighbors, I want one of everything of what they have. And when I do that, I'm going to get a multiple that will be the least common multiple. So the idea, I look at my neighbor who's the 16, and they've got all these twos here. Well, I want a 2. So I'm going to cross it off. I'm going to write this on my little list of numbers to multiply together. I've got a 2. And the person on the right has a 2 as well. So I already have one of those, so I'm going to cross that off. Then I go back to the person on the left, and I go, ooh, they have another 2. I want that one. I write down that 2. The person on the right has a 2. Guess what? I already have that, so I'm good. Then I go back to the person on the left, and I go, ooh, they have another 2. I need that one. I'm going to multiply by that one. They have a second 2. I'm going to multiply by that one. Now I'm not going back to this guy until I'm done with all the 2s. And then I realize, ooh, this person has a 5. I need a 5. I need one of what each of my neighbors has. Notice that I crossed off these 2 because I already had copied what the neighbor on the left had. So I need the least amount of things that involves making sure I have one of what everybody else has. And so the idea is if I multiply all these numbers together, that's going to give me the greatest common factor. It's kind of a weird way. So the other way that I want to show you is the least common multiple using a factor ladder. And so I'm not going to multiply this all out yet because I want to show you what happens when I do a factor ladder. So with a factor ladder, you already know how to do this, right? We write down the primes. So over here, I'm going to write 2, 3, 5, 7, 11, and I'm going to start dividing by 2. I get 8 and 10, divide by 2 again, I get 4, and I get 5. So here's the deal, that you know, like you're really good at making factor ladders, and you're going to circle those 2 numbers, and you're going to multiply them, and you're going to find the greatest common factor. But this time, we're looking for the least common multiple. And it turns out when we factor out the common factors, ooh, there's the 2 2s that both of the neighbors had. Remember how I put those 2 2s in my group, right? And then check it out. There's a 4, which happens to be these 2s, and there's a 5. And so when I do the factor ladder method, it's really cool. You make an L, and all of the numbers inside the L get multiplied together, and that's my least common multiple. So 2 times 2 times 4 times 5. So 4 times, I could do this, right? I can multiply these 2, multiply these 2. The commutative property says I can move some things around, and I'll still get the same answer as long as I'm just multiplying numbers together. So now I have 4 times 20 is 80. So my least common multiple is 80. So you're basically making a factor ladder, and then you're multiplying the common factors with the factors that only belong to the guy on the left and the guy on the right, so that you have a little bit of what everybody has. Okay, next. Oh, yeah. Go ahead, write these down, pause it. I'm going to show you the answers. Right, my primes, 2, 3, 5, 7, 11. Divide by 2, I get 7 and 9. These have no more common factors, but I need to multiply all these numbers together. 2 times 7 times 9. I do 14 times 9. 9 times 4 is 36. Carry the 3, 126. So the LCM equals 126. All right, next, let's divide by 2. I get 14 and 18. Divide by 2. 7 and 9. Ooh, that's weird. Same number there. Okay, make an L. Multiply all those numbers together. 2 times 2 times 7 times 9. Here's what I'm going to do. I already know that 2 times 7 times 9 equals 126. So I'm going to cheat a little bit and say 126 times 2, right? This is all 126. So now all I need to do is go 2 times 126. Can I do this in my head? 252. All right, next. The last one, divide by 2. I get 12, 45. Oh, let's see, divide by 3. 12 divided by 3 is 4. 3 goes into 45 15 times. This is where I stop because there were no more common factors, and I make my L 2 times 3 times 4 times 15, which is 6 times 60, which is 360. And that's how you use the ladder method to find the least common multiple.